Right. Hi everyone. Welcome back. In this video, we're going to be talking about derivatives from first principle. So first principle is defined by this equation: f prime x equals sign limit of h turning into 0, f at x plus h subtracting f at x, and then everything divided by h. This is the formula that you use when you derive using first principle. So we have three main questions that we can expect from first principle. The first one will be a quadratic, followed by cubic. And then lastly, you have a rational. So these are the ones with fractions. These are the ones that have fractions in them. So this is how the question is going to be asked. This is how the question is going to be asked. They'll be saying determine the derivative of f at x from the first principle. So you need to start by writing the definition, which is saying what? F prime x equal sign limit h turning into 0, and then f at x plus h subtracting f at x. Remember, you have to divide by h. You have to divide by h. And then next step is going to be equal sign limit h turning into 0. At this point, you are going to realize that from the equation or from the question, you are only given f of x. You only have f of x, which is what? Which is x squared plus 1. You are not given f of x plus h, but then you can use this to look for f of x plus h. Then your f of x plus h is going to be x plus h squared plus 1. So technically, you're just replacing x with x plus h, and then you simplify. So simplification of this by means of expansion is going to be x squared plus 2xh plus h squared plus 1. Therefore, this is the expression that you'll be writing whenever you see f at x plus h. So going back to our formula, whenever we have f of x plus h, this is what we write: x squared plus 2xh plus h squared plus 1. We need to subtract what? X squared plus 1. This is f at x plus h, this one. And then this one is f at x. Remember, you need to divide by h. You need to divide by h. So our next step will be simplifying by distributing the negative. So you're going to be writing limit h turning into 0, x squared plus 2xh plus h squared plus 1. So you're going to be saying negative multiplied by x squared. This will be negative x squared. And then same thing applies to negative multiplying 1. This will be negative 1. Remember, you have to divide everything by h. You have to divide everything by h. Right? Right. At this point, I expect you guys to see that we have what we call like terms. What are going to be our like terms? You're going to say 1 minus 1. This will be 0. X squared minusing x squared, you'll also be having 0. So the only things that we are left with now is going to be 2xh plus h squared. Those are the only terms that we have in our numerator. Remember, everything has to be divided by h. I hope we are still okay. Then we are going to be at a step where we have to say we have two terms in our numerator. Out of the two terms that we are having, we have something common. We have what you call highest common factor, which is going to be what? Which is going to be h. So you're going to factorize according to highest common factor. H is going to go out, and then you have 2x, and then you are left with a single h here, and then everything divided by divided by h. Then you're going to say this h will take care of this one. They go out on a date. Yeah. And then your limit approaching 0, you're left with 2x plus h. However, remember that the statement is telling us that h is turning into 0. Then your final answer will be 2x, because you are now going to consider h as 0. It's going to be just 2x plus 0, which will just remain as what? As 2x. And at this step, when you are writing your final answer, you are not expected to keep this expression or to keep this notation of limits. So our final answer is going to be 2x. I hope it makes